Okay. Ground improvement techniques, its relevance of ground improvement and its emerging trends. By Chitra CJ. So good evening all. So today we are going to discuss relevance of ground improvement and its emerging trends. In a construction project, there are numerous foundation problems that are encountered during the execution phase. Soil in its natural form at a construction site is not suitable for the construction or to bear all the loads that is coming over it. For such situation, the soil needs to be modified to increase its bearing capacity and decrease its failure or settlement tendency. So that modification of its property is called ground improvement. So let's see, ground improvement techniques are used when the behavior of the fill mass or the underlying soil does not meet required design criteria. So the soil and beneath the foundation should be able to withstand the load that is coming over it. Ground improvement is carried out for the following purpose: to prevent excessive settlement of the surface, to improve the shear strength of the fill and subsoil, to ensure sufficient bearing capacity of the foundation or sufficient stability of the slopes. And also it increase the density of the fill mass and to prevent the liquefaction and improve soil permeability in order to increase drainage capacity. So these are the need for ground improvement. So when you do a construction project on a site, the main problem that we come across is a problematic soil in the site. The problematic soils are those soil which need some treatment before or after construction of foundation. These soil exhibit properties which are undesirable to any foundation, that is excessive movement. So when we construct a building over such type of soil, it will undergo rapid settlement and thereby causing damage to the building. These soil must be identified in the field before construction is planned. So when you like when you start a project or design a building, we should first visit the site and identify which type of soil is beneath the foundation, and we should study the property of the soil. And if it is not properly, if it is not able to withstand, or if it is not having sufficient bearing capacity, we should modify the property of the soil. So that is called ground improvement technique. So what are the problematic soil? Different types. First is expansive soil. Expansive soil contains minerals such as metal clays that are capable of absorbing water and increase its volume. Thus exert enough force on building or other structures to cause damage. So when water is applied to the soil, it undergoes rapid expansion and thereby causes additional load to the building. So that type of soil is called expansive soil. And the another characteristic of the soil is when it dries out, it suddenly shrinks. So there is a rapid change in the volume of this types of soil, that is called expansive soil. And when it shrinks down, what happened is it removes the support from the foundation and the building suddenly falls down. Okay, so the example is black cotton soil. So in the figure, you can see the cracks formation in the soil. When it dries out, you can see the cracks. Now, next type of problematic soil is collapsible soil. Collapsible soil are those unsaturated soils that can withstand relatively high pressure. That can withstand high pressure. So that is called collapsible soil. Upon wetting, they are susceptible to a large and sudden reduction in volume. Example is pure gravel. And next type of problematic soil is soft soil. The water content of the soil is very high, Thus, modification is required to reduce the water content. Example is marine clay and peat. So in this figure, you can see the problems of a collapsible soil. Here you can see when the water is applied, you can see a sudden pit that has formed. So that is called collapsible soil. As the name indicates, it will suddenly collapse down. Okay. Example is pure gravel. Now, next type of problematic soil is organic soil. The organic soil is the construction. When the construction is of a organic soil, it's typically of low strength and high compressibility. And the example is, and the organic content of these type of soil is very high. And the next type of problematic soil is car deposit. Soil are formed by the dissolution of soluble rock like limestone, gypsum, etc. They have very less density also. So these are the various types of problematic soil. Identification of problematic soil. So how we will identify if it is a problematic soil or not when we visit a site. The ability to identify problematic soil is of exceptional value to constructors and geotechnical engineers. Identification is done both by experience and testing. So the some of the testing that we conduct in geotechnical lab has been used to identify the characteristic of the soil and find out whether the soil is problematic or not. So the first property that we are testing on the laboratory is swelling and plasticity index. Either swelling test or PI test is conducted to estimate the magnitude of possible swell in a clay. So hope everyone is familiar of swelling and plasticity index test. Next is the liquid and plastic limits. That is the next property that we should check. Liquid limit and plastic limit values also help to identify the type of problematic soil. The identification of problematic soil. The ability to identify problematic soil is of exceptional value to the constructors and geotechnical engineers. So, the properties that we test are swelling and plasticity index, liquid and plastic limit. These are the properties that we test to identify whether our soil is problematic or not. Okay, now if you do the swelling test in the laboratory, plastic index is if it is over 35, the potential volume change will be very high. And if it is ranged to 22 to 48, the potential volume change will be high, moderate high. And if the swelling test, if the plasticity index values ranges from 12 to 32, then the volume will be, volume change will be medium. So these are the range to which we can expect the volume swelling test values. Then next is plasticity, liquid and plastic limit range values. Liquid limit 30 to 60 percentage, and if the plastic limit is 20 to 25 percentage, we can say that it is a collapsing soil. Okay. Now next is geomaterials. If the soil, if the soft clay, if the material is soft clay, the problem that we are facing is low strength, high compressibility, and low permeability. If the soil is of silt, it has high liquefaction, high erodibility, low strength. If it is expansive soil, it is of large volume change. We can expect a large volume change. If it is a dredge material, we can expect high water content and low strength. If it is solid waste, non-uniformity, and high degradation potential. If it is organic soil, we have large creep formation, high compressibility. And biomass byproduct, it has low strength, high degradation potential. So these are the characteristics of the problematic soil. That is not much that important. The question will be like, what are the problematic soil that we come across? The question will be like that in the exams. And what are the tests that we conduct normally to predict the problematic soil? Okay, so the main test that we are conducting is swelling test and a plastic limit and liquid limit test. And cause of failure in problematic soil is man-made. Excavation can cause tunneling, pile driving, rapid drawdown of surface water, elevation of surface water. So these are the problems that we can expect. Then next is natural conditions. Due to natural condition also the sudden settlement of the soil occur. That is presence of problematic soil materials like clay, then high groundwater table, inclined bed rock, and steep natural slope. So all these are the natural conditions by which we can predict the natural settlement of the soil. And what are the solutions or alternative methods that we can adopt to avoid this problematic soil? So these are avoid a particular site. If a particular site is having a problematic soil to a great extent, then it's better to avoid such site for construction. Next is design the construction accordingly. So based on the type of the soil, we can modify the foundation so that it can withstand the load that is coming, and design the plan structure accordingly based if it is flexible and rigid structure. Then next is remove and replace unsuitable soil. So soil replacement can be done to modify the foundation soil, removing organic topsoil which is soft, compressible and volumetrically unstable, and replace it with more hard soil. Attempt to modify the existing ground, enable cost effective foundation design. So all these are the possible solutions that we can take to improve the site condition. Okay. Ground, so when you talk about the problematic soil, the solution is ground improvement techniques. So when it was introduced, the solution to problematic soil is to use certain methods which can improve the strength and quality of geomaterial that is present, that is soil. Then modern ground improvement methods were developed since 1920s. At present, more than 50 ground improvement techniques are available. So these are the history of ground improvement technique. It starts by 1920s. So ground improvement techniques, historical background. First, it was like vertical sand drains. In 1925, we used sand drains to improve the quality of soil or to improve the bearing capacity of the soil. And in 1926, we used cotton fabrics as reinforcement to improve the characteristics. In 1937, it was vibro compaction method. So all these methods we can discuss in later classes. Then prefabricated vertical drains was introduced in 1947. Henry Vidal reinforcement for retaining walls in France. He introduced reinforcement for retaining walls. So all these are the history of ground improvement techniques. So based on the type of ground improvement that we are adopting for a particular site, we can classify the ground improvement techniques into foundation type, based on the soil type, based on its function. So prefabricated vertical drains means we should insert concrete columns or stone columns into, like we should dig certain pits into the soil, and we should fill that pit with concrete or stone. So that is called vertical drains. So that we will discuss later in the next modules. You have to study that in detail. Then different criteria to classify the ground improvement technique. First is a deep foundation, shallow foundation. And based on the soil type, we can take the ground improvements like fine grain soil, granular soil, cohesive and non-cohesive soil. And based on the function performed, it can be densification, replacement, drainage, consolidation. So all these are the types of ground improvement techniques that we are using based on the soil properties. Okay. And what are the frequently used techniques? Frequently used techniques is densification. Frequently used technique is densification, that is a rapid impact compaction. That is, we are compacting the soil using some equipments or machines. We are compacting it and thereby densifying the voids or eliminating the airs from the void so that its density increases. Next is vibro compaction. Vibrators, we are using vibrators to compact the soil. So using all these techniques, we can densify the soil. Now next is replacement. Replacement is if the soil is of high problematic characteristics, it's better to replace that soil with more uh, more strength soil. Okay, that is called deep soil exchange. Then use of admixtures like lime, then cement materials. All these can be used as admixtures, and the technique used is called grouting. So grouting is the adding cement to the soil. So that is called grouting, and we can also add lime. Now next is thermal treatment. We can use temperature to alter the properties of the soil. Now next is piling technique, which is the common method used for foundation, that is piling technique. So all these are, it's just a brief idea about the various techniques that we are using for ground improvement. We'll study in detail in the next modules. Okay, densification, replacement. Then next is selection of ground improvement techniques. Selection of suitable ground improvement technique is based on the following parameters like structural condition, geotechnical conditions, environmental constraints, construction condition, reliability, and durability. So all these are the factors based on which we select which techniques to be used. So we discussed about certain techniques, and all these techniques cannot be applied simultaneously. We should select which type should be used, or which type is more suitable for your particular site. Okay.
So let's see the classification of ground improvement techniques. There are basically four mechanisms by which we can alter the properties of soil.
Then next is classification of ground improvement techniques. Next is classification of ground improvement techniques. Can you see the slide? Okay. Now next is classification of ground improvement techniques. So that is 4 groups of ground improvement techniques are distinguished. First is mechanical modification. Classification of ground improvement techniques. There are mainly 4 groups of ground improvement techniques that we commonly adopt. First is mechanical modification. Second is hydraulic modification. Third is physical and chemical modification. And fourth is modification by inclusion and confinement. So in mechanical modification, we are compacting the soil so that the voids, the air inside the voids are expelled or the water inside the voids are expelled. And in hydraulic modification, we are removing the water by consolidation techniques. And in physical and chemical modification, we are adding admixtures to the soil. Okay, so these are the 4 types of ground improvement techniques that we commonly adopt. First, let's see what is mechanical modification. In mechanical modification, let's discuss what is compaction, a simple ground improvement techniques where the soil is densified through external compactive efforts. So in compaction, we have shallow compaction, deep compaction. In mechanical modification, we are using rollers or vibrators or plate vibrators, rollers, etc. to modify the density of the soil. Okay, so there are 2 types of compaction, shallow compaction and deep compaction. Okay, in the figure you can see that when what is the effect of compaction. After the compaction, what happens is the water will get expelled and we can see how the voids are eliminated and how the soil gets densified. Okay, now these are the equipments used for compaction. First is smooth wheel rollers, vibratory rollers, sheets foot rollers, pneumatic rubber tire rollers. So these are various roller types. Hope you have seen these types of rollers in road. So when you use these types of roll, what happened is the water inside or the air inside the voids get expelled out and the density of the soil increases. Now next is hydraulic modification. In hydraulic modification, it's just a brief idea, okay? I will explain in detail later. Next is hydraulic modification. In free pour, so in hydraulic modification, we are expelling the water out from the voids of the soil. In coarse grain soil, this is achieved by lowering the groundwater level through pumping from boreholes or trenches. In fine grained soils, the long-term application of external loads or electrical forces required to expel these water from out. Okay. So this is hydraulic modification. So in hydraulic modification, we are expelling the water from the voids of the soil. Next is physical and chemical modification. In physical and chemical modification, additives includes natural soils, industrial byproducts of waste materials, fly ash, slag, cementatious and other chemicals, lime and cement, which react with each other and modify the property of the soil. And this is so we can modify the chemical property or physical properties of the soil by adding admixtures. So this type of modification is called physical and chemical modification. Soil stabilization by heating the ground and by freezing the ground are called thermal method of modification. And this method is mainly used in gravel. So in the figure, you can see a truck applies chemical stabilizers to reduce the soil erosion where vegetation cannot be planted. Here, when chemicals are applied to the soil, the properties of the soil changes. Then next is modification by inclusion and confinement. Modification by inclusion and confinement, we can insert fibers, stripes, bars, meshes and fabrics into the soil. So it's like it's like RCC beams. If we insert this reinforcement inside a beam, what happen, it increases the strength. So similar is the principle here, that is we are inserting fibers, strips, bars, meshes, so that the strength of the soil increases. So in the figure, you can see the geotextiles have been inserted into the road, and over that we will apply or we will put soil so that it increases the strength of the soil. Okay, so that is called modification by inclusion and confinement. Methods of soil improvement: reinforcement by stone columns, soil nails, micropiles, jet grouting, ground anchors, geosynthetic fibers, lime columns, vibro concrete columns, mechanically stabilized earth, and biotechnical. And ground improvement by surface compaction, drainage, surface electroosmosis, compaction grouting, blasting, dynamic convection. So all these you need to study all these topics in the, I have uploaded all that in my class. So just go through it and study these types of soil improvement techniques. Okay. Then now next is ground treatment. Soil cement is applied, lime admixtures is applied, fly ash, dewatering, heating, freezing, vertification. So all these are the techniques that we adopt to improve the strength of soil. Factors affecting the choice of improvement method. First is soil type, area, desired, required soil properties, availability of materials, availability of skills, environmental concerns, that is cost. So all these are the main factors that we should consider for adopting the techniques. Now let's see what are the emerging trends in ground improvement techniques. So in the latest techniques are the use of or recycling. So main concept is the sustainability, that is reusing or reducing the waste. Okay. So the concept is environmental geotechnics and solid is used for ground improvement technique, or use of waste or containment and constructive use of waste material, low cost technologies with soil and additives, geosynthetics, biotechnical stabilization, development of new machinery, particularly for deep compaction, availability of new construction materials like geoforms and geocomposites. So all these are the emerging trends in ground improvement techniques. Future trends. Following future trends in ground improvements are combination of technologies. So we can combine the following technologies to suit the particular site, or smart automated improvement technologies, use of recycled materials, performance based specification, advancements in biosynthetics. Emerging trends in ground improvements are geotextiles. Geotextile polymer is made from polyester or polypropylene. It is taken into account to be strong, very durable. There are two types of geotextiles. There are woven and non-woven. So these are the picture for geotextiles. Next is geogrid. Geogrids are plastics formed into a very open net-like form, which can be inserted into the soil and can improve the soil property. Next is emerging trends in ground improvement techniques. Next is geonets. Geonets are all made of polythene. The molten polymer is pushed out through slits in opposite rotating dies. So it will be like a net structure which can be inserted into the soil and which can alter the property of, or we can improve the strength of the soil. Next is geocomposites. The basic philosophy behind geocomposite material is to combine the best features of different material in such a way that specific application are addressed. So two or more geonets or geotextiles are combined together to form geocomposites. Next is cellular confinement system. CCS is also known as geocells, are widely used in construction for, also known as geocells are widely used in construction for erosion control, soil stabilization on flat ground and steep slopes, earth reinforcement, etc. So you can see it's like a honeycomb structure made full with land, great stones, building materials. Okay, thank you. So all these are about the ground improvement techniques, latest ground improvement techniques. Okay, hope you understand what I have taught. Thank you. So I'll just go through the topics that I have taken. So hope you remember the topics. So we discussed about need for ground improvement. So it increase the shear strength, the density, and permeability. And we talked and we discussed about what is problematic soil in a site. Problematic soil are those soil which need treatment before or other construction of foundation. Then next is different types of problematic soil. First is expansive soil. Expansive soil is the soil which rapidly changes its volume when water is applied. And it suddenly shrinks when they are dried out. The example is black cotton soil. So you can see that. And next is collapsible soil. The collapsible soil property is suddenly collapse down when water is applied. Example is gravel. Example is marine clay and peat. Different types of problematic soil. Next is organic soil, then karst deposit. Then how we can identify problematic soil is we can conduct swelling and plasticity index tests, liquid and plastic limits test in laboratories. And if the range is with 35, 22, 48, 12 and 32, high, very high, high, medium is the range of volume change in swelling test, and in liquid and plastic limit test it is If the liquid limit is 30 to 60 or plastic limit is 20 to 25, we can expect collapse. Okay. Now these are the cause of failure. Then what are the solutions? Avoid particular site, or we can modify the property of the soil, or we can modify the or we can modify the design of the building so that the building can withstand there. Okay, and the modification of the property is called ground improvement technique, and it was developed in 1920. At present, more than 50 ground improvement techniques are in use. The historical background is 1925, vertical sand drains were introduced. That is, in pits we can fill cement or stones. Okay, now next is classification based on foundation type, classification based on soil type, and functional performed. So frequently used technique is densification, next is replacement, use of admixtures, and thermal treatment and filing technique. Then selection of suitable ground improvement technique is based on the following parameters: structural conditions, geotechnical conditions, environmental constraints, construction conditions, and reliability and durability. And there are basically 4 types of ground improvement techniques: mechanical modification, hydraulic modification, physical and chemical modification, modification by inclusion and confinement. And we discussed about what is mechanical modification. It is a compaction in which we apply rollers or vibrators over the surface of the soil, thereby expelling the air or air from the voids. So these are the equipments used for compaction. In hydraulic modification, we can expel the water from the voids of the soil by consolidation techniques, and it is mainly used in fine grained soil. Then next is physical and chemical modification. Here we can add admixtures like fly ash cement or fly ash cement to modify the properties of the soil. In the figure you can see a truck that applying chemicals over the slope. Now next is modification by inclusion and confinement. By inserting the fibers, strips, bars, meshes into the soil can modify the properties of the soil. So in the figure you can see how a geotextiles is being installed into the road to modify its property. So that is called modification by inclusion and confinement. And let's discuss in detail what is a ground improvement techniques. So mainly used ground improvement technique is stone columns, soil nails, micropiles, jet grouting, ground anchors, geosynthetics, and ground improvement techniques or ground improvement can be done by surface compaction, drainage, electro-osmosis. So all these techniques can be studied in detail with my next classes. Okay, I'll just discuss in next class in detail about all this. Then factors affecting the choice of improvement method is soil type, area, desired required soil properties, availability of material. Then what are the emerging trends in ground improvement? Like combination of technologies, smart automated improvement technologies, use of recycled materials, performance-based specification, advancement in biosynthetics. So all these are the trends that we can expect in geotechnical improvement techniques. So mainly used material is geotextiles. Geotextile is like a polyester or polypropylene, like a net structure. Next is geogrid. Geogrid is more of like a net-like form. It can be inserted into the soil to improve the property. Geonets are all made of polythene, similar to geotextiles. Then geocomposites, a combination of geonets and geotextiles. Next is cellular confinement system, CCS. Here it is a honeycomb formation of polypropylene, can be inserted into the soil and can improve the strength. Thank you. Any doubts? You can chat here and clear the doubts. If you have any doubt, you can ask.